Welcome to the lecture on fractions. We're going to review how to do some simple operations with fractions, beginning with reducing them. So if we have the fraction 42 over 49, to reduce a fraction like this, you need to think about what number or common factors divide into 42 that also divide into 49. It might help to break this down into its prime factorization. You don't have to do that, but it will make sure that you've established all of the possible numbers that go into 42 and 49 and cancel them out. So for example, if we think about 49 in the denominator, 49 is 7 times 7, and those are prime numbers, so they're not going to break down any further. 42 is 6 times 7. Now 6 actually isn't a prime number, so it could break down further. So if you wanted to write out the true prime factorization, it would look like this. 6 is 2 times 3, and if we multiply that by 7, we'll get the full 42. So the top 2 times 3 times 7 is the prime factorization of 42. 7 times 7 is the prime factorization of 49, and now that we have it completely broken down, we're just going to cross off any factors that are the same on the top and the bottom. So what we're left with is the 2 times 3, or 6, and the 7 on the bottom. So this reduces down to 6 sevens. Now you could have done that up here, just canceling out the 7s, but I just wanted to show you how you could also do it with prime factorizations. Let's take a look at 11 27s. Now 11 is another one of these prime numbers, which means it's only divisible by 1 and itself. So 11 is not going to break down. 27, hopefully you know, is 3 times 9. If you wanted to break that down into its prime factorization, 9 breaks down even further. It's another 3 times 3. So that's what the prime factorization of 27 looks like, 3 times 3 times 3. Do any of these 3's divide into the 11? No, which means there's no common factors on top or bottom, so nothing cancels out. So the 11 is going to stay 11, and 3 times 3 times 3 is that 27. So this already was a reduced fraction. Okay, let's try 88 divided by 20. So 88, there's a lot of ways to get 88. My first instinct would maybe be 8 times 11, but you could get it using 4 times 22 or 2 times 44. There's lots of ways to get 88. Now 8 doesn't have, or isn't completely broken down yet. It's 4 times 2, and that isn't completely broken down because 4 is another 2 times 2. So this would be the complete prime factorization of 88, since these are all the prime numbers that multiply together to give you 88. Now let's look at 20. 20 we know as 4 times 5, and 4 can be broken down into 2 times 2. So the prime factorization of 20 is 2 times 2 times 5. So now that we have it completely broken down, we can cross off the common factors. I see a couple 2's on top and bottom and another couple 2's on top and bottom that match. So what we're left with is 2 times 11, which is 22, and just a 5 on the bottom. Now notice that this answer, 22/5, that's called an improper fraction because the number on top is bigger than the number on the bottom. You could also, if you wanted to, convert this into a mixed fraction. And the way that you would do that is to think about how many times does 5 go into 22. Well, we know that 5 times 4 is 20. So the most number of times that 5 is going to go into 22 is 4 times. But since that's only going to give you 20, there would be 2 left over, 2 out of 5. So 4 and 2/5 is the same as 22/5. This is called the mixed number. This is called the improper number. Both are acceptable answers. Alright, now that we know how to reduce fractions by looking for common factors on top and bottom and crossing them off, now we're going to move into multiplying fractions. And the basic rule for multiplying fractions is to multiply top times top over bottom times bottom. So we're going to do that on this next example. If I multiply this top times this top, 3 times 7 is 21, and then this bottom times this bottom, 8 times 9 is 72. So that's my initial answer. However, it may not be reduced. So what we want to do is make sure that it's reduced, and you can use that prime factorization. On this one, I'm just going to kind of use a little bit of a shortcut and think about a common factor that I know has to go into 21 and 72. They're both divisible by 3. 21 was 3 times 7, that's how we got it in the first place, and 72 is 8 times 9, or 8 times 3 times 3. So one of these 3's is going to cancel out, and what we're left with on top is the 7, and what we're left with on the bottom is 8 times 3, or 24. Now, here's another option for you on this problem. Instead of doing 3 times 7, or top times top, over bottom times bottom, instead I might want to reduce first instead of just multiplying straight across. So what I would do in that case is think of this as one entire big fraction bar. If I see any numbers on the top that I know divide into numbers on the bottom, then I can cancel them out. So for example, I know 3 goes into this 9 3 times. 7 does not go into 8, and 7 does not go into 3. So that's as much canceling as I can do. Now, since I used this 3 completely up, you can, if you want, write a little 1 there. There's a factor of 1 left over. So here what I've done is I've reduced first, and now I'm going to do top times top over bottom times bottom. So the top is 7, and the bottom would be 8 times 3, or 24. So it's the same answer that we got down here, just by reducing first and then multiplying. So let's try another example. We have 4 times 3/8, and this one doesn't look like a fraction times a fraction. It just looks like a whole number times a fraction. But we can easily fix that problem by turning 4 into a fraction. And you can do that if you are a more visual person and you want to think of tops and bottoms. So 4 can be thought of as 4 over 1. Now, if we want to do the same trick that we did before, look at all the tops, 4 and 3, and the bottoms are 1s and 8s. So is there any number on the top that also goes into the number on the bottom? We know that 4 goes into 8. So let's divide by 4. 4 goes into 4 once, 4 goes into 8 twice, so we're going to be left with a 1 times 3 on top, which is 3, and a 1 times 2 on bottom, which is 2. So our answer is 3/2. Okay, let's try one more. So we have 15/4 times 8/3. Let's expand our fraction bar here. Do I see any numbers on top that have common factors with numbers on the bottom? Yes, we know that 3 divides into 15 5 times, and this 3 is going to get used up. And I know that 4 divides into 8 twice, so that 4 is going to get used up. So what's left is 5 times 2, which is 10, and on the bottom, 1 times 1 is 1, and I wouldn't leave my answer as 10 over 1. I would go ahead and reduce that to just 10. So multiplying fractions, top times top over bottom times bottom, but you might want to reduce first before you multiply across. Now, if you can do multiplying of fractions, you can do dividing of fractions because they're almost identical. There's just one extra step involved. When you divide fractions, you need to first change this division problem to multiplying by the reciprocal. And the one that you're going to take the reciprocal of is the second fraction only. So for example, if I have 4/5 divided by 5/16, we're going to change this to a multiplication problem. We leave the 4/5 the way it is, we change the divide to a multiply, and we take the reciprocal of the second fraction. So that just means flip it over. So 5/16 becomes 16/5. Now I'm going to do the same thing that I did before, which is to think of this as one big fraction bar, and I'm going to look for any common factors on the top and on the bottom that I could cancel out. Now on the bottom, all I have are 5s, and on the top I have a 4 and a 16, which are not divisible by 5s. So what that means is nothing's going to cancel out. So we're just going to go ahead and multiply. Top times top would be 64, and bottom times bottom would be 25. So my answer is 64 25ths, and I know it's reduced because we didn't have any common factors. Okay, let's try it again. So I have 7/10 divided by 14. First thing I'm going to do is change this to a multiplication problem. And in order to do this, you might want to take that 14 and put it over a 1, turn it into a fraction. So this is going to become 7/10, changing this division to a multiply, and 14 over 1 flips over and turns into a 1 over 14. Now I want to multiply across the tops and the bottoms, but before I do that, look to see if you can cancel any factors out. We know that 7 divides into 14 2 times, and I'm going to use up that 7. So what I'm left with on top is 1 times 1, which is just 1, and on the bottom I'm left with a 10 times a 2, which is a 20. So my answer is 120. Okay, last one here for division, same idea. We're going to leave the first fraction the way it is, change this division to a multiply, and flip over the second fraction only. So it becomes a 10/3. And then I'm going to expand my line here, and I'm going to look to see if I have any numbers on the top that divide into any numbers on the bottom. Well, you can see right away that the 3's are going to cancel each other out, so they're going to go completely away and go to 1's. Now 8 doesn't go totally into 10, but they do share a common factor. They're both divisible by 2. So if I divide 8 by 2, I'd be left with 4. If I divide 10 by 2, I'd be left with 5. So now that we've reduced, let's multiply the leftovers. We're left with 1 times 5, which is 5, and 4 times 1, which is 4. So my answer is 5/4. The last thing we're going to talk about is adding and subtracting fractions, and this is actually a little bit tougher to do than multiplying or dividing, because when you multiply or divide, you can have any fractions at all that you multiply or divide, but with adding and subtracting, you can only add or subtract fractions that have the same denominator. You have to have common denominators. So let's practice a couple of easy ones that already have common denominators. So if I have 3/10 plus 2/10, if you have a common denominator already, that denominator is going to stay put, so it stays 10, and all you do is either add or subtract the numerators. So 3 plus 2 is 5, and then you will always want to make sure that your final fraction is reduced. So 5/10, we know that that's not reduced. 5 goes into 5 once, 5 goes into 10 twice, so this is really the same as 1/2. Okay, now let's try subtraction. 5/3 minus 1/3, they have a common denominator of 3, and if I subtract the two numerators, 5 minus 3 would be 4. And 4 and 3 do not share any common factors, so this is already reduced. Now let's try a couple that don't have common denominators. So if I have 2/5 plus 1/4, first thing I want to do is look at the two denominators that I have, and I want to come up with the least common denominator, the number that's the smallest number that's divisible by both 5 and 4. And the easiest way to get that here would be to just multiply them together since they have no common factors. So 5 times 4 is 20, so that's a good choice for a common denominator. And in fact, it's my least common denominator. So what I want to do is change these two fractions into two new fractions that have this new denominator. So to figure that out, think about what it takes. What do you have to multiply 5 by to get 20? We know we have to multiply by 4. So to balance out this fraction, whatever you do to the denominator, you also have to do to the numerator. So we're going to have to multiply the numerator by 4 as well, and 4 times 2 makes this 8. So all we really did here is multiply by a fancy version of 1, which is why the fractions are still equivalent. Let's try it again for 1/4. We know that to go from 4 to 20, I'd have to multiply by 5 on the bottom. So to keep it balanced, I have to multiply by 5 on the top. So that makes the new top 1 times 5, or just 5. Now that my denominators are the same, we're going to keep that denominator equal to 20, and we're just going to add the two tops. 8 plus 5 is 13. 13 is prime, so this must be reduced. Okay, this next one has 3 fractions in it. So first thing we're going to do is look at all of our denominators, 2, 22, and 11, and try to figure out what the least common denominator should be. Well, I know that 2 times 11 is 22, so if I used 22 for my common denominator, all of these numbers would be divisible by that. So 22 is the perfect choice. So we're going to rewrite each fraction so that it has 22 in the denominator. Now, for the first fraction, it had a 2 in the denominator. So to go from 2 to 22, I have to multiply by 11, so I have to multiply the top by 11 as well. 11 times 1 would be 11. So there's my new fraction. 1/2 is the same as 11/22. Now if we look at the middle fraction, it already had 22 in the denominator, so I didn't have to change anything. So I don't want to change the numerator, it's going to stay 17. Then for the last fraction, to go from 11 to 22, I have to double it. I have to multiply it by 2. So I have to double or multiply by 2 the top as well. So the new top is 2 times 2, or 4. So now they all have a common denominator. So I'm going to keep 22 in the denominator, and now I'm just going to add and subtract going left to right. So 11 plus 17 would be 28, and then 28 minus 4 would be 24. Now is this reduced? 24 over 22? No, you know that it isn't because these are even numbers, so you know at the very least they're both divisible by 2. So let's divide by 2. 24 divided by 2 is going to give me 12, and 22 divided by 2 is going to give me 11. 11 is prime, so nothing else is in common between these two numbers, so this must be reduced. Okay, the last example here has mixed fractions that we want to subtract. Now there's a couple ways to do this, but I'm going to just show you a way that's similar to how we've already approached these other problems. And the way to do that is to convert these into improper fractions first. So let's review how to do that. If you have 3 and 1/6, to convert this to an improper, you're going to multiply the 6 times the 3, which would be 18, and then you're going to add in the top number of that fraction. So 18 plus 1 means this is the same as 19/6. 6 goes into 19 3 times with 1 left over, so that's why it's the same as 3 and 1/6. Let's do that same thing on the second fraction. 12 times 1 is 12, plus 11 more, so 12 times 1 is 12, plus 11 more would be 23. So this is going to be 23/12. So those are the two mixed numbers now turned into improper fractions. So to subtract these, I can't until I get a common denominator. So I'm going to look at my two denominators, 6 and 12, and what do both of these numbers divide into evenly? Well, the smallest number that works would be 12 itself. So I'm going to change these two fractions so that they have a 12 in the denominator. Well, the first fraction had a 6, so to go from 6 to 12, I have to multiply by 2. So I need to multiply the top by 2 as well to keep it balanced. 2 times 19 is 38. Second fraction already had a 12 in the bottom, so I don't need to change it at all, so I don't want to change the top either. So now I have a common denominator of 12, that's what it's going to stay as, and I'm ready to go ahead and subtract my two numerators. 38 minus 23 is 15. Last but not least, is this reduced? Hopefully you see that it isn't, because 15 and 12 are both divisible by 3. So if I divide 15 by 3, I'm left with 5. And if I divide 12 by 3, I'm left with 4. and 4 and 5 do not have any common factors, so this is reduced. Alright, that concludes our lecture on fractions. Good luck.